What's up, everybody? Today's the day, part 2. In this series, we're showing you how to unlock your car with your iPhone. And if you haven't seen part 1, I suggest you go back and check that out. But in this video, we're going to be building the Bluetooth module. Now, I'm pretty excited about this because this Bluetooth module can actually be applied to a wide range of projects and all sorts of things. So I'm excited, you're excited, let's just get into it, you know? Hey, can we roll the cool parts montage? There's no one there. Alright, so I'd just like to take a second here to let you know that if you're interested in following along with any of these projects, the links to everything you'll need are down in the description below. And I'd also like to say, if you're enjoying this content, please consider subscribing. Alright, so first things first here, we've got the Arduino. And this is actually an Arduino Nano, and geez, I love these things because you can just do practically anything you want with them. And we've got these little pins that we can actually stick this on. You see there's a problem here because it's got some leeway, and we want a sharp 90-degree angle. So the best thing that I like to do to fix this is to use a breadboard. So I've just laid those little tracks right down in the breadboard, and that's going to give me a nice even 90 degrees for these two things so that I can solder them in there. I like to run my soldering iron at 350 degrees Celsius, and that is 662 degrees Fahrenheit. I've got my soldering iron with my sponge, and we've got our fume extractor right here for any of the solder fumes. I'm going to start by soldering all 4 corners of this Arduino just to get a nice solid grip on it, and then I'm going to continue on with the rest of the pins. Alright, so now that we've got that done and everything's soldered in there, we're going to go ahead and just pry that, and then boom, we've got a perfect 90-degree angle. And now, like magic, we can just put our Arduino right on our perf board like that, and we're ready to solder it on. Alright, so let's talk about placement just for a second. Now I've got the Arduino as far back this way as possible, but I've left one set of rings right along here just to, that'll come in handy later. This is the opposite side right here. We can see our line of rings right there, and the side with the micro USB. I actually think it's a mini USB. Now we're just gonna clip these right off. Alright, so we've got our Arduino on, and we're going to be using pins D12, 11, 10, and 9 to control the 4 buttons on our key fob. Now let's look at the Arduino on paper. So for example, with pin D12, it's going to output 5 volts. Like all of the other digital write pins on the Arduino. But we've already said in the previous video that the key fob needs to run on 3 volts. So we need to build a voltage divider here where we've got 2 resistors in series. In this configuration with 1K at the top and 2K at the bottom, we'll achieve 3.3 volts right here going to the key fob. And 3.3 is going to be good enough for us in this purpose. When we write our Arduino program to output 5 volts on pin D12, we end up getting 3 volts going to the key fob. And as we discussed in the previous video, that will tell the key fob to do nothing. When we write a digital low or 0 volts on pin D12, we get 0 volts going to the key fob, and that will tell the key fob to do whatever is connected to this button. Alright, so let's get into it. So we've got our 1K and our 2K, and really I couldn't find 2K. This is 2.2K. I think it's going to do just fine. We have 4 pairs for each of the 4 buttons. We've got 1K on the left, 2.2K on the right. Make sure to keep them separate because honestly I'm not that great at reading colors. So we're going to talk about placement for these for a second. We've got pins the 12, 11, 10, and 9. That's where the resistor is going to be going. And over here we have the digital ground. And we're going to want all of the 2K over here to be near that ground. And we're going to want all the 1K over here to be close to these output pins. We're going to go ahead and start with the 1K resistors. Now we want this to be as condensed as possible. And really you'd like something like this. The wire is up close to the resistor and it makes it really easy to fit in a tight spot. So on the board this is going to go right about here. And it should just fit right in like that. Now that we've got it in there, we're going to flip the board over and go ahead and bend the resistor leads while pressing on the back side of the resistor to really make sure it stays in place there before we solder. And we're going to solder each one of these before we insert the next resistor. Now we've got all 4 resistors with the top looking like this. This is getting a little dry, isn't it? Let's go ahead and put these 2K resistors in and get back to the music. We've got our 2K resistors on there, and we've already discussed previously that the 1K resistors and the 2K form a voltage divider that allows us to send 3.3 volts to the key fob. We're going to switch gears here and take a minute to talk about the Bluetooth module. Now the reason for this is because when you're assembling the board, we're going to need a voltage divider for this thing, and the resistors fit really nicely next to the resistors that we've already put in. This Bluetooth module has 4 pins. 1 pin for power, 1 pin for ground, which is pretty self-explanatory, but it also has a transmit and a receive pin. So the Bluetooth module receives information on the receive pin and transmits it back to the Arduino on the transmit pin. This voltage divider is going to be for the Bluetooth module. We've got our 1K and we've got our 2K, and right here we'll have about 3.3 volts. That means that when we want to transmit from the Arduino to the Bluetooth module, we'll write a series of 5 volts and 0 volts here, and a series of 3 volts and 0 volts will be sent to the Bluetooth receive pin. Now according to the data sheet, the receive pin takes about 3.3 volts, which is the reason for the voltage divider. And lucky for us, 3.3 volts is what we've already been producing with the same resistors that we've had previously. So we're going to grab one more pair of 1K and 2K resistors and make a voltage divider for this that's going to fit nice and snug next to the other resistors. The 2K resistor belongs right next to the other 2K resistors. And the 1K resistor is going to go right next to the previous 2K resistor. So now your board should be looking something like this. And the next step is to add the female connectors to insert the key fob. This is where this line of rings comes in handy. We've got a 3 volt power source right here and we have a ground right here. So we're going to have a size 2 female connector about right here. And for controlling the key fob buttons, we'll have a size 4 female connector right about here. That's 6 in total because we already discussed that each of these buttons gets a command wire, so that's 4 command wires, and we need to provide power and we need to provide a ground. That brings us to 6 total. This is the female connector we're going to be using, and I don't have a size 2, so we're going to need to cut one of these in half. So these connectors are going to go right here and right here. That way the right side of this female connector is connected to that 3 volts. And we have the ability to send a ground wire right over here to this ground. Let's go ahead and solder these things in there. Now the female connectors are soldered in there and we're ready to move on to the next step, which is to add the Bluetooth module. So I want this Bluetooth module to fit one ring away from the side and the 1, 2, 3rd ring right in there. Now our Bluetooth module is securely in place. Now this next part is going to get a little hairy. It's the final step and we're going to be connecting everything up. So buckle your seatbelts and get ready for the ride. So far we haven't been connecting anything. We've just been soldering parts onto the breadboard and nothing's going to work right now. I mean, none of the components are connected to each other. Each of the 1K resistors have to be connected to the Arduino and to the female connector. All 5 of the 2K resistors are going to be connected to this ground. This 1K resistor is going to be connected to D3. It's then going to be connected to this end of this 2K resistor. The path would be a connection from D3 through the 1K resistor through the 2K resistor to ground. That's where we tap our 3.3 volts for the receive pin. We will need a wire coming from about here over to this receive pin, and we're going to need a wire coming from D4 over to the transmit pin. Then we're going to need to provide power and ground, and we're going to need to provide 5 volts to the Bluetooth module. Then, coming back to this female connector, we're going to need 4 wires for each of the individual channels coming over to these 4 2K resistors. For this female connector, we're going to need to connect to this 3 volts, and we're going to need to run a wire over to this ground. And that should be all the connecting that we'll need. Now this is sort of the part of the video where you've probably got to watch it a couple of times to get a feel for what's going on, because there's a lot to go through here. But we're probably just I'm going to talk a little bit, but we're mostly just going to fast forward through some of this connecting. These shorter connections between the 1K resistors and their associated pins can be done with just adding a little bit of solder. However, the longer connections, like bringing power to the Bluetooth module, is going to require a wire. When you're doing this, you're going to want to make sure that the solder stays between this connection and this connection, and it does not have any short circuits between the two. I'm planning on connecting the back ends of all of the 2K resistors together, and then at one point tying it into the ground. Be very careful to get the right ground. So far this is what we have. We've got our 1K resistors connected to their associated pins. We've got the other side of the 1K resistors connected to their pins on the female connector. We have D3 connected to its 1K resistor, which is then connected to its 2K resistor and then connected to ground. All of these 2K resistors are grounded right here at this point, and we've connected the 3 volts to the size 2 female connector. Now we're going to have to add some wires. I've prepared 4 wires for bridging the gap between the female connector and the 2K resistors. And the first white wire is going to be soldered in like this. Now we've connected the wire to the female connector and associated 1K resistor, and we've connected the wire to the first 2K resistor, thus completing the first voltage divider. We're going to go ahead and finish the next 3, then get back to the camera. Now we've got all 4 wires in there, and they're connected to this female connector and the 2K resistors. That will allow us to control our key fob with the 3.3 volts at each of these 4 pins, controlled by the 5 volts at D9, 10, 11, and 12. This is what the backside looks like. We've integrated our wires into the 1K resistors and the female connectors, and they come along here, and then each of them on their own channels is connected to the 2K resistors, which are then connected to the ground. Now it's time to connect the Bluetooth module wires. The transmit is going to come through a wire over here to D4, and the receive is going to tap right into this voltage divider we've created with these 2 resistors, which is then controlled by D3. We're first going to attach the receive wire at the voltage divider. We're about to solder these in there. Now one end of the blue wire is attached to the receive pin of the Bluetooth module, and it comes over here and is now attached to the middle of the voltage divider that we created for the receive pin. Now we've inserted the transmit wire coming from the transmit pin of the Bluetooth module over to the pin D4 on the Arduino. Now we're going to solder that in. Now the transmit wire is connected. The transmit pin is connected to the transmit wire via this joint, and the wire comes over here to pin D4, and then this is the joint that connects the wire to D4. We've only got a couple connections left. We need to provide power and ground to this Bluetooth module. So we're going to bring the 5 volts from this pin right here and the ground from this pin over to these on the back via black wires. And we're going to have one more black wire coming from this ground over to the left side of the size 2 female connector. That will provide our ground to the key fob. We're going to take this first wire and run it from the left side of the size 2 female connector all the way to the second pin right here on the Arduino, just like that. Alright, so we're done. We've got the left pin of the size 2 female connector attached to this black wire, which is attached to the second pin, which is the ground of the Arduino. We've got this ground running from here to the ground of the Bluetooth module, and here the fourth pin is the 5 volt supply, which runs through this wire and is connected to the power pin of the Bluetooth module. So everything is soldered up and connected, and we're done. This is what the top of your Bluetooth module should look like, and just note that this is a ground connection right here between those 2 back ground wires. Now there's a couple problems with this board right now. See, it really doesn't do anything, and that's why in the next video we're going to have to program the board and get everything working. We're going to have to use some ATX commands to configure the Bluetooth module. We're going to write an Arduino program that communicates with the Bluetooth module, and depending on what the Arduino receives from the Bluetooth module, we'll do different actions on these pins, which will result in different actions on the key fob. We'll also have to solder the wires onto the key fob and get it attached to this module, and that's what you can look forward to in the next video. Alright people, that's a wrap. This was a really exciting project for me because the same principles used to design this Bluetooth module can be used to design a Bluetooth module to control anything, really. It's up to you. And if you have anything to share, go ahead and comment. If you like the video, like it, and if you want to see more, feel free to subscribe. Thank you.